Alright, so we'll be starting chapter 17. Our first lesson will be over describing weather. First vocab word, weather. The atmospheric conditions along with short-term changes of a certain place at a certain time. The important thing to remember here is short-term. We start talking long-term, we're talking climate, not weather. Air pressure is a word we've had before. This is the force that a column of air applies to the air or a surface below it. So below it is important there. Humidity is the amount of water vapor in the air. Relative humidity is the amount of water vapor present in the air compared to the maximum amount of water vapor in the air that the air could hold at that temperature. So, this is going to be important in terms of temperature. Warm air can hold more water than cold air, which we'll talk about a little later on. Finishing off the vocab, we have precipitation, water in liquid or solid form that falls from the atmosphere. The water cycle is another one that we've had, is the series of natural processes by which water continually moves along or among oceans, land, and the atmosphere. Alright, so our weather variables, that's what we're going to be talking about for this entire slideshow. We will have our kind of lead up top, so in this case our lead is air temperature. Air temperature is a measure of average kinetic energy of the molecules in the air. So the faster thing, or the higher temperature you measure, that means more kinetic energy. That means things are moving faster. This can vary depending on time of day, season, location, altitude, you name it, right? Just things that can change the temperature. Direct sunlight could be one of those things. Air pressure. We've talked about this before. Again, this is the force exerted by a column of air on a surface. This is measured with a barometer. So barometric pressure is another name for air pressure, and its label is millibars or bars, and then the mill is the prefix there. Air pressure helps us to predict weather. We talked about this last chapter, where we had low pressure, meaning that we had warm air or warm surface. Wind, high pressure to low pressure. We've talked about this before, so we're always flowing from high pressure to low pressure. It is named by the direction from which it is blowing. So if wind is blowing from east to west, those are going to be called westerlies. We talked about this before as well. A lot of this stuff, as you can start to see, we've kind of hit on a little bit before, so we're going to be moving pretty rapidly through this. Wind speed is measured by an anemometer. And that is what this looks like. You might have seen a few of these out maybe in the country. They have weather stations kind of sprinkled around, and this would be at the very top of it. Humidity is measured in grams of water per cubic meter. So a humid day means that there's going to be more water vapor in the air. So the reason that your sweat doesn't evaporate as quickly when it's humid out is because there's already a lot of water in the air, so there's nowhere for the water off your skin to go. That's why it seems like you're sweating a lot more. That's not entirely the case. The case is that you're just not evaporating as quickly as it normally would. So relative humidity is the amount of water vapor in the air compared to the maximum amount of water vapor that the air can hold at that temperature. Relative humidity is determined by the temperature. So again, warm air will be able to hold more moisture than cold air will be. Saturated air holds as much water as possible. That's what the word saturated means. It means it can't hold any more. It is measured by a psychrometer. It is given as a percent. At 100%, the air cannot hold any more water. So at 100%, the air is completely saturated. It will become rain or dew if it tries to hold more than 100%. So, what we see in some cases is, and we can flip to the next slide here, we see here if we're at 30 degrees Celsius, which is maybe around 90 degrees, and we have the same amount of water vapor for 30 degrees Celsius, 20 degrees Celsius, and 10 degrees Celsius, this is a 28% relative humidity because, well, again, warm air can hold more water vapor than cooler air. Here, at the same amount of water vapor at a cooler temp is 52% relative humidity. And then we get down to 10 degrees Celsius, and we have 100% relative humidity. So that would be saturated air. When it gets to that point, when it gets to this relative humidity, that's when we start seeing dew form, or when we start seeing rain form. That's why you see dew in the morning after it's been a cold night, or frost in the morning after a cold night. Dew point is the temperature at which air is saturated and condensation occurs. This is what we were just talking about. Normally reached when temperature decreases at night. And this is the reason for the frost on the grass. So we have the water vapor in the air, and as temperature starts to come down, the relative humidity stays the same. So we have the same amount of water vapor, but we start to become more and more saturated. And as we become more and more saturated, at some point it hits the dew point, which is a temperature. And when it hits that temperature, that's when it starts to condense into liquid or even frost. Clouds and fog. As warm, moist air rises, again, so this is that water vapor that we have in the moist air, it cools. When it cools, it reaches its dew point. When it reaches its dew point, water vapor condenses, and it has to condense onto something. So it condenses onto anything that's in the atmosphere: dust, salt, pollution, smoke, whatever it might be. Watch those Bill Nye videos where he lights a few matches and tosses them in there, and he used that for them to condense on. The water droplets or ice crystals below the light. This is what we see as clouds. This should be block the light. We'll change that right now. Block the light. That's why we see clouds. So we get as many of those, we get all of those water droplets and ice crystals, and that's what blocks light. So that's how we see clouds. There are different kinds of clouds that we're going to talk about right now. Stratus clouds are flat, white, layered clouds and have an altitude of up to 2,000 meters. Cumulus clouds are fluffy, heaped, or piled, kind of look like cotton balls. They go from 2,000 meters to 6,000 meters. And our last ones, cirrus clouds, are wispy. They're really, really high up. They're about 6,000 meters up in the air. Well, sorry about that. We'll continue here. Precipitation, droplets in clouds that are large enough to fall back to Earth. So, rain we know is a liquid, snow and hail are both solids, sleet is a solid that is melting as it's falling. So because we know it gets warmer as we get closer to the surface, so that's why it can melt as it's falling. Snow can melt and refreeze as it falls. Hail is a small piece of ice that is repeatedly lifted and then dropped by an updraft. Ice is added with each lift, so as it's being pulled back up, it's hitting more and more water, and it's turning to ice, and so it's getting bigger and bigger and bigger, and eventually it gets too heavy, and it can't be lifted back up. So if we have a really, really strong updraft, that's how we get really big hail. Our last slide here is going to be over the water cycle. I mean, we've talked about this before, we've been tested over this. We have precipitation, which runs into, which is the runoff. We have the surface runoff here. The transpiration from the trees, if it's taken up through there, or evaporation. Then we have that condensation. Condensation leads to precipitation. Hopefully that's just straight review. That will do it for lesson 1.